In this video, I'll be discussing the 2013 AMC 10B problem, question number 23. In triangle ABC, AB equals to 13, BC equals to 14, CA equals to 15. Distinct points D and F lie on segments BC, CA, and D respectively, such that AD perpendicular BC, D perpendicular AC, and AF perpendicular BF. The length of segment DF can be written as m over n, where m and n are relatively prime positive integers. What is m plus n? So, we know that AB equals to 13, AC 15, BC 14. AF perpendicular BF, so F equals 90 degrees, D perpendicular AC, and AD perpendicular BC. Now, to solve this problem, we will actually first need to identify something called a cyclic quadrilateral. A cyclic quadrilateral, what is that? Well, it's basically a quadrilateral that can be inscribed in a circle. So if I draw one here, you have a circle. And then if you just draw a quadrilateral with such that the 4 points of the quadrilateral are all on this circle, then you can get that this quadrilateral will be cyclic. But you might be wondering, do you have to draw a circle for this problem? Well, no. For this problem, we know that AFB equals to ADB. Actually, this will be sufficient to find that it's a cyclic quadrilateral, because only in cyclic quadrilaterals will when the diagonals, the intersection of the diagonals will cause that these two angles will be equal. And this can be easily proven by the inscribed angle theorem of circles, but that's for another video. So, since angle AFB equal to angle ADB equal 90 degrees, so ABDF, so ABFD is cyclic quadrilateral. And then using the theorem I told you and property, well, the other pair of diagonal angles are going to be equal. So angle ADE, where this one, will equal to angle ABF. Here's this one. And then of course, we get similar triangles. So triangle ABF will be similar to triangle ADE, because angle AFB equals to angle AED equals to 90 degrees. Angle ABF equals to angle ADE. This will be by the angle theorem. And now we also can get that triangle ABF will be similar. No, triangle ADE will be similar to triangle ACD, because this can actually be by the right triangle altitude theorem, but because we know that ADC equals to 90 degrees and AED equals 90 degrees, so I can write it down. Angle ADC equals 90 degrees equals to angle AED. Angle DAE equals to angle DAE, because that's the shared angle. So we can get that triangle ADE similar to triangle ACD by AA. Okay, so now what do we do? Well, now I can try getting some side length. The first one I want to get is going to be AD. So, by Pythagorean theorem, I can get that 13 squared, which is AB squared, minus BD squared, will equal to 15 squared, which is AC squared, minus CD squared, which will equal to 15 squared minus 14 minus BD squared. Simplify. After simplification though, you will get that BD equals to 5. Plug it in, so AD will equal to 12. And then 15 squared minus 7 squared is also equal to 12 squared. Goes 49 plus 144. No, 15 squared minus 14 minus 5 equals to 9. So 15 squared minus 9 squared equals to 12 squared. So we can get that to AD equals to 12. And then, of course, DC equals to 14 minus... Wait, no. DC equals to 14 minus 5 equals to 9. Okay, so by similar triangle properties, we can get that the longer side, the longer leg to the hypotenuse will always be in the ratio of 9 to 12, which is 3 to 4. So then we can get that. So BF to AB, BF to AB will equal to BF to AB. So let's look at this one. BF. So BF to AB will actually equal to 3 over 5 times 13. Because we can get that the shorter leg will be in the ratio of 3 to 5. Wait. I'll adjust the paper a bit. Because I just told you that since BD equals to 5, DC equals to 9. And then we know that BF over AB, well, by similar triangles, this one will equal to BF to AB. This one will equal to D to AD. And well, D to AD. What would that be? We know that 80 equals to 12. So we can get that DE. It wouldn't be that hard to find. I can write it here. DE, 15 DE equals to DC, which is 14, with 9 times 80, which equals to 9 times 12. 80 equals 9 times 12, DC times 80, 9 times 12 equals to 108. DE would then equal to, DE will equal to 15 times 9. But no, that will equal to 15 times 7. Yeah, 7. Which will equal to 108 over 15. Which will equal to, simplify that, equal to 36 over 5. So DE to AD will equal to 36 to 5. So DE over AD equals to 36 over 5 over 12. So then that will equal to 3 to 5. So BF to AB will equal to 13, 3 times 13. So yeah, that is how we get it. Then similarly, in same logic, we can get that. So BF equals to, or AB equals to 3 over 5, and then BF will equal to 3 over 5 times 13. Okay, now, similarly, we can get that AF equals to 4 over 5 times 13. So now we know AF and BF. And don't forget ABDF is a cyclic quadrilateral. So now I will introduce the most important theorem in cyclic quadrilaterals when solving for sides, Ptolemy's theorem. So what is Ptolemy's theorem? Ptolemy's theorem well, it basically means that, say we have this circle, and then we have a cyclic quadrilateral inside. And then we connect the diagonals. So let the diagonals length be E and F. And then let the sides be A, B, C, and D. Ptolemy's theorem states that the product of the diagonals, which is EF, equals to the sum of the opposite pairs of sides. So we CA, the product of the opposite pair of sides. So CA plus BD. So then using the theorem, we can get that. But for us, to make it easier, let X equals to DF. Because that's what we want, right? So we will get that 13x plus BD times AF, which equals to 5 times 13 times 4 over 5 times plus 5 times 13 times 4 over 5 this will equal to 12 times 13 times 3 over 5. So after simplification, you'll get that X equals to 12 over 5. 18 over 5. Wait, 13x, so yeah, I got this wrong. It'll be 16 over 5. 16 over 5. So m plus n equals to 16 plus 5 equals to 21. So the answer will be B. So what is the key point of this problem? Well, first of all, know that it's a cyclic quadrilateral. Then we use similar triangles. Using the Pythagorean theorem, we find the length. Then we use similar triangles again, the ratio, to get from this to this. So we can get the side lengths of BF and AF. Then we use Ptolemy's theorem, which is EF equals to CA plus BD, to find what X, which is DF, equals to. Then we can just find the answer, 21. Thank you for watching.